Hi, it's Tony and Rob here, co-founders of Great Ideas. And in this video, we're going to follow on a series that we've been discussing around how to modernize .NET applications like web forms towards leveraging .NET 6 and Blazor. And in this discussion, we're going to take a deeper look into what are some of the optimal backend record storage and search designs out there. If you look at the different permutations or options that are available using relational databases, NoSQL, other permutations around that, hybrid models, what we've found that's really effective with our product in Trellispark. So we can share some of our thoughts and ideas around what we've been able to achieve as well. So, Tony, the first thing that we want to ask is, what are the trends in modern software architecture that we should even consider today?
Okay, so there are three major themes in mainstream software architecture that have an impact on modernizing a web form application and building an optimal record storage solution. The first is the move to single page applications, so SPAs, where we want a much more engaging user experience, something that's a lot more real time, that's faster, the performance is better. So examples like Angular, React, and so on, Node.js. Essentially what we're looking for is how can we simplify the creation and update of the pages, and this actually has a major impact in the design of the backend record management system as well that we need to consider. The other trend that's emerging in mainstream is, the idea of document databases. So things like NoSQL. So MongoDB would be an example of this, and we'll look at a more detailed example of MongoDB later. And essentially, even these document databases, where essentially we're storing a JSON or an XML record in a table, are still using a relational hybrid model when you look at the indexing, so that they can optimize the queries and the search capabilities. So the next major thread that we need to consider is the idea of document data agnostic storage using something like, say, JSON XML, and how that ties into a relational hybrid database structure. The next thing we need to consider, obviously, is microservices versus monolithic. So in the past, a lot of applications were built monolithic, where essentially all of the data was held in one big database, and effectively we created, a huge application silo. And then as we've looked at microservice architectures and implementations over the last decade or so, we've started to see that fragment and essentially people deploying data across multiple microservices. And essentially what we've done is we've fragmented our monolithic application and that big database into lots of little, smaller service level. So, we may have had an application that had, say, customers and orders and order lines. We're now basically a customer service and an order service that contains the order and the order lines. And essentially the data is fragmented, and we've actually created more application silos, not less. And this has basically led to concurrency issues and all sorts of other fun stuff, right? Now, when you look at all of those three trends combined, so the single page application, the document database, the microservice, and you look at where we're seeing the architectures and the best practices trending into what the application architectures over the next 10 years are going to be, you start seeing a move towards something that we're describing as data agnostic services. So this is essentially taking the microservice approach further, is actually, instead of putting the application data inside a service or inside an application database, is abstracting the data into its own data service layer. If you're looking at, say, the idea around document databases and storing data agnostically in JSON and XML, there is an ultimate path that it's a great idea to use data agnostic services for record storage, because then whenever we change a field or we change a column, we're not making changes that cascade through our whole application. And then finally, for single page applications, obviously, if we've got true data agnostic record storage, we've got the ability to do dynamic page building as well. So essentially, these three key trends, single page application, document relational hybrid databases, and microservices, are moving towards this idea of data agnostic services. And essentially, what we're going to be talking about today is, how do you build the state of the art data agnostic record storage?
Okay, so based on all of that, then how do these trends impact our typical CRUD or create, read, update, delete user experience and the underlying models around that?
Yeah. So essentially what everybody's trying to do is write less code. I mean, the bottom line is that every single line of code that as a developer I have to write, at some point, I have to actually have a requirement for that code. I have to design that code. I have to develop that code. I have to test it, deploy it. And then when something changes, then I'm going through essentially a regression test and essentially making changes right the way through my application stack. So what everybody is trying to do is eliminate as much of the CRUD code as possible, right? I mean, it's boring. It's like, how do you get the record off the screen into the database, put it back on the screen so the user can edit it? So the trend as a whole is to eliminate that CRUD code. Now, one option that we've seen is essentially to hide the CRUD code. So you see a lot of common no-code, low-code solutions. They're still underlying under the hood. They've got a relational table model. They've got columns in tables. And you're dragging and dropping elements onto some sort of dynamic form builder. And in the background, it's creating the columns on the business objects to actually get the data out of those tables and render that into the fields. And essentially some of that code is, well, a lot of that code is essentially being hidden unless you as a developer need to actually understand it so that you can go in and customize it. So now essentially where we're dealing with these low code, no code solutions that are hiding the code, then as a developer, you really need to understand how that code is hidden so that you can customize it. And the problem with that is that, again, because that code actually exists within a very rigid framework, your options for being able to customize that code are in a sense being limited. So that's one option, the hide it option. It's very common. You know, you see a lot of systems out there that are essentially going through this model. So the other option, okay, is to work towards actually eliminating the CRUD code. Okay, so the idea here is, why should we have to even write create, read, update, delete code for customers, orders, order lines, right? I mean, why do we even have to write that code? Because again, the point of using these single page applications and document DB technologies is that we ought to be able to move towards a user experience that's rendered dynamically based on who the user is, what record we're displaying, the state of that object, and we ought to be able to take that user experience, render it dynamically, capture the information that we need about the record, put that into data agnostic storage, and then we're done. Okay, so the idea is either we can hide the code, the relational model, we just hide it, and then we're dealing with the consequences, the optimizations and stuff related to very rigid model, or completely eliminate it. And if you look at the trends of where we're going with SPAs and document relational databases, essentially the ideal solution that we'll probably see emerge over the next decade around data agnostic services is the ability to actually completely eliminate the requirement for building that CRUD code.
Okay, so definitely, like what we've been seeing in a lot of different ways and in the trends in the industry is trying to eliminate the need to be able to write the code, and there's different options based on what you've described. Either we can use like a no code, low code solution that actually is essentially hiding the need to be able to write that because you're constrained within what that user experience can do, and then you don't have to write it yourself, or you're taking a different approach that you're describing here, where you actually eliminate the need completely to actually write that code based on a data agnostic approach. What is the approach that would achieve the best result in the long run then? I mean, are we somehow limiting what we can do in a user experience by taking one approach to another? What's the best result?
So to get the best results, what we really want is true data agnostic record storage. Okay, so it shouldn't matter what I'm storing, right? Whether it's a customer, whether it's an order, whether it's a vehicle, whether it's a policy, whether it's a page, it shouldn't matter, okay? Because what we want to be able to say is that our single page application, our page builder, is completely data agnostic. So from a page builder perspective, if we can get to a point where it truly doesn't matter that this record is a customer or an order. That's getting us to a point where the page builder is able to actually interpret the information it's retrieving from the database and provide a user experience. And it's not making any assumptions that this data is coming out of a customer table or this data is coming out of an order table. It's just saying, hey, I've got this record. I want to be able to build a page to display it. Now, if we can achieve that, then what we've got is maybe 5,000, 10,000 lines of code in a single page application page builder solution that's dynamically rendering any page from a combination of, here is the record I want to display. It happens to be a customer. Here is a data definition of what a customer form looks like. So take this customer record, take this form or page definition in data, combine the two and render the user experience. And then the next time the page refreshes, it takes a order record out of the database. It takes an order form definition in data out of the database, puts those two together and renders the user experience. So the idea is that with a single page application, the ultimate objective would be arbitrary record out of the database, a user experience data-driven definition out of the database, combine the two with a small amount of code as possible. So write a dynamic page builder that says the user experience should look like this for this combination of this record and this form. And that's the ultimate, that's what we're all really trying to achieve.
Okay, well, let's explore this then a little bit further. If we're going down the path of data agnostic record storage, what are the things that we need to consider in building an optimal data agnostic record storage?
Okay, so essentially, we really need to consider the nature of the data in our applications. Okay, whether or not it's a customer or it's an order or it's a, it doesn't matter what sort of application we're building. Let's first of all think about the nature of the data. Now, one acronym that we don't hear a lot of is WORM, W-O-R-M, write once, read many. Okay, so when you think about a lot of the data that we store in our applications, whether it's a customer, whether it's an order, okay, how many times do we actually write the record? So we might write the customer information when we get the customer. Maybe once or twice a year, something on that customer record changes and we update it, right? When we've got an order, obviously we write the order into the database and we may change the order a couple of times as we go through the fulfillment process. But we write the records very infrequently, and then those records sit there for years, right? I mean, 7 years for financial data is typical. Okay, now consider the number of times we read that record or we search or query that record. Okay, if I've got a customer in my database, I've written that customer record maybe once or twice a year, but I've probably pulled that customer record up as part of a search or a filter criteria hundreds of thousands of times, maybe even millions of times, right? So one thing that we need to really consider, as I say, is the worm nature of the data, right? So we write it once, we read it a lot of time. Okay, so what this feeds in is to the whole command query responsibility segregation model, a CQRS model. Okay, so there is a very big difference between the commands that we're going to execute as part of the write strategy, so creating the record in the first place and updating it as we need it, and then the query strategy, which is how do we get the information out of the data agnostic record storage in an efficient and effective manner. So one of the things that we're going to need to really think about as we build an optimal data agnostic record storage solution is how are we going to implement the CQRS model to really address the worm nature of our data.
Okay, so then in that vein, then if we're addressing this ability to be able to read the information really well, be able to write once and then read many times. What's the optimal storage solution then in that kind of architecture where you're using data agnostic record storage in that approach?
Okay, so as a lot of things in IT, right, we're looking for a hybrid solution, right? There's a difference between the command and the query side. Okay, so the first thing that we've learned around the command side is don't use a relational table to store the record. Okay, because as soon as you create yourself a customer table and you put a bunch of columns on it, then it's not data agnostic anymore. Any read or write to the customer table means that you need to understand that there is a customer table and here are the columns that I need to read and write data into. And if they're typed, right, then I need to put a date in this column and a number in this column. Okay, so first lesson is that on the command side, we can't use a relational table to store the record. Okay, because any changes that we make to that table, so we add an extra mandatory column, we change the type of a column, we make a string column from 10 characters to 20 characters, potentially has knock-on impacts throughout the rest of our application. So lesson one, okay, don't use a relational table to store the record where we've got a table with a bunch of columns.
Okay.
So what we want to do instead is save that record using a data agnostic format. So the lesson that we should be taking away from that is that we need to save our records in a data agnostic format. So XML or JSON are the two common alternatives that are available right now.
Okay, then if we were to look at different examples, so let me share an example of something that we found off the internet. So in this case, it looks like they're using MongoDB and they're structuring their data this way. Is this an example of data agnostic record storage?
So this example that we're seeing here has a lot of the good features of data agnostic record storage. So here, for example, you can see that they've created 4 separate tables and that each of the tables has a primary key, and that the information about the record that's being saved is stored in JSON. And this is a really good start, right? I mean, essentially, because we've got a data agnostic version of a customer, it means that I can store any customer in this table. So, for example, there may be differences between, let's say, a corporate customer and a non-profit and a consumer. Right, a person like you or I. There may be different fields, different information I want to capture about those 3 different types of customer. And certainly going this way, where I've got a JSON representation of what a customer is, gives me that flexibility to be able to deal with multiple customer types and to be able to add or remove fields from those type definitions without breaking anything. Okay, so from that perspective, we are already moving towards really good data agnostic storage solutions. One thing that I would sort of like look at here is say, well, okay, I've got 4 tables. Okay, so if you remember our early discussion from the CRUD, okay, I've got to know that there's a customer table or that there is an order table.
Right.
So it's not I'm just pulling an arbitrary record out of the data set and I'm good to go. Here in this sort of architectural framework, I still need to know that I need to go to the customer table to pull customer JSON, or I need to go to the order table to pull order information. So this is a good step along the way. I've got a lot of the data agnostic benefits that I was looking for in the case of multiple customer types and easily being able to add or remove fields, but having to put all of these into 4 separate tables in this example, I'm not all the way there. We could go further.
Okay, so then what would be going further?
So going further would essentially be putting all of the records into a single table, right? So essentially, instead of having a customer, an order, and an order line and an item table, we just have one table. Let's call it instances. So we just got one table called instances that holds all of the records in the database.
Okay, but well, hold on a second then. I think a lot of folks that are listening to this are going to say, what? Put everything in one table? That sounds crazy. Like how would putting all of your data, all your records into one table actually be optimal for things like search and doing complex queries and that sort of thing? Like, how are you getting around all of the other challenges that you have and just putting everything into one table?
Yeah, I mean, this is the fun bit that we had when we were building Trellis Spark and earlier iterations of our frameworks, right? Is that if you put all of the data into one table, then there are a bunch of benefits that you're going to get out of it, and we'll talk about those as well. Okay, but I mean, it's like scary, right? Any developer looking at this and saying, "Oh Christ, you put all of the records into one table," how efficient is that going to be, right?
Yeah.
So the first thing that we need to remember, okay, is it's the CQRS model, right? It's our worm data. Okay, so creating and maintaining the data is not the same as querying it. Okay, so the objection is not how do we save the data and benefit from that. The objection is, well, okay, how do I query that information effectively? Okay, so putting everything into a single table, great for creating and maintaining the data. Lots of advantages to doing that, and we'll talk in detail about some of those advantages later in the in this presentation. But the problem that we really need to solve, and took us a year or two to actually figure out ourselves, was how do you query that information efficiently? How do you get the performance of an optimized relational database from a document database where you stuck all of the records into one great big table?
Okay, so then how are you going to solve querying the data efficiently? First question.
Yeah, okay, so let's say we spent a couple of years figuring this out, and we ended up building some really cool code generation technology to help us do it. But we were looking at the underlying mechanisms of how databases work, how you do the searching and filtering. We looked at all sorts of things like putting an XML index on an XML column in SQL Server, and can you query that efficiently? Can you put like a full text index over it and query that efficiently? So what we did was we took an approach where we added a whole bunch of information to the instances table in terms of metadata to help us query and select records optimally. And then we looked at, okay, great, you know what, if we really need to be able to query this data at the same performance as you would get from a relational database, then there isn't really a choice. You do have to create a set of read-only lookup tables that hold the key fields that are necessary to execute your queries. So as you're building your CRUD application, you get a sense most of this thing is parent-child, right? So then, essentially we can do a lot of our joins based on that information. There may be other fields that we need. So for example, if we're storing information about vehicles, we might want a lookup table that summarizes just the vehicle records, which contains just the fields that we need to filter the vehicles. So vehicle data may contain, say, 150 different fields, but all we really need to search on is make, model, year, maybe, right? So let's create a read-only lookup table for a vehicle that has make, model, year. All right. Now that is then the smallest physical table that we can put on the database, and our databases are then going to be able to query that table really quickly. And then what we do is we say, okay, great, we created these lookup tables, and essentially within Trellis Spark we do it through essentially applying a simple trigger on the instances. So as the instance record comes in, it's shredded, the results go into the lookup table, and you know what, it costs us a millisecond. I mean, it's like ridiculously small, because on a row by row basis you shred the XML, you update the record table, the lookup table with that record. It's as a read-only resource. It's minuscule. I mean, the effect is not noticeable on the save. So on the command side, the fact that we are storing the information in one big instances table completely data agnostically, and then using that with a trigger to populate a lookup table, as I say, negligible performance impact on command, and worm nature of data, we do that very rarely. Okay. Now, once you've got these optimized lookup tables that contain just the fields that we ultimately need to search and query on, then we can look at, do we want to create additional indexes on those lookup tables, right? To actually further optimize the search capability of the lookup tables.
So then you put everything into one large table, and then you've created a series of lookup tables to be able to then index those lookup tables to get the optimal search. How is that any different than what we were doing in the case of the example that I was showing before?
Well, one thing that we can do, right, when we're creating these lookup tables in the Trellis Spark variation of this, right, is that we can go further than just creating a lookup table for a customer or an order or an order line. So one thing that we can do when we're maintaining our read-only lookup tables is that we can create additional lookup tables that maybe flatten those joins. So it's very common when you see an application that you'll see, the same join with 3 tables or 4 tables or, sometimes 10 tables repeatedly in the system. So what you can do as part of the command side of this, as you create the lookup tables, you can do it in hierarchies, so that if you change, say, customer information or order information, that you're actually updating a combined table, which is essentially flattening that join out. Now, we've seen examples where we've been joining million row tables, but sort of like 3 levels of hierarchy, and by flattening them out, we ended up with a table that was still millions of rows. But when we executed the query, instead of the query having to do the join and the join's waiting for seconds or sometimes minutes for the join to complete, the fact that we created a lookup table that spanned 3 tables and actually eliminated the need to do the joins basically meant that that query was returning in milliseconds. Now, when you think about it, okay, let's say I've spent an extra couple of milliseconds creating this level 2, level 3 lookup table in the database, but every time, the hundreds of thousands or millions of times a year we're actually running a query, I'm using that read-only lookup table, and instead of the thing taking seconds to process, it's taking milliseconds to process. You can see the obvious performance benefits of doing that. So one of the approaches that we're doing within Trellis Spark when we're looking at how do we actually optimize these read-only lookup tables is we don't stop at level 1. We don't stop at a lookup table for customers and a lookup table for orders and a lookup table for order lines. We actually build lookup tables that flatten out some of these common queries.
So let me just show what we were sharing before again for just a moment, because I just like to go back to that and just clarify something that you're describing there, because I mean, what you're describing is like indexing a bunch of lookup tables. But when I look at something like this and the example here, they've moved towards creating indexes as well. Ultimately, is this where you need to be? So whether you were to take this approach in the case of like MongoDB and JSON, and then you're basically organizing things, and then you're creating a bunch of indexes to optimize search. What is ultimately the point of then having everything in one table? What am I missing there? Why is it that it would be so useful to first have everything in one table and then bring it out? Because ultimately, are you not still indexing all of this stuff anyways? One way or the other, you're indexing it in order to get the performance optimization that you want, whether you're using the lookup tables or not.
Yeah, so essentially, what we're saying is if you put a bunch of records, if you put that stream back up for a minute, Rob.
Yeah, I will, yeah. Because I think it's an interesting point that you're raising here, and I'd like to make sure we're clarifying.
Okay. So here's the bottom line, right? You're running a program on a computer that's going to a database, and a database is a set of records stored in pages. And if you want to run a query on that data, okay, you are going to need some mechanism of querying that information. Okay, so you're going to be writing some form of SQL that's going to be looking at each of the records in turn. It's going to be looking at the fields in the record and return a set of rows to you. Okay, that's it. I mean, that's what relational databases do. We've been doing this for decades. We're really good at it as an industry. We've built a ton of SQL query analyzers that are essentially going to optimize searching for data among disparate data sets. Okay, that's
and to your point, Tony, some of the latest technologies coming from Microsoft and Microsoft SQL Server, that stuff has been optimized to the nth degree around being able to do that kind of search query optimization, right?
Yeah, exactly. As I say, we've been doing it for years. We're really good at it, okay? And there's no magic, right? You can't just create a JSON record or an XML record, stick millions of them in a database, and then say, well, you know what, without creating any indexes or lookup tables, we're going to be able to search this quickly, okay? We tried it. Right, we tried it with XML indexes in SQL Server years ago, and the answer is, even simple queries over 30,000 records were taking 30 seconds. It just doesn't work, right? I mean, you just can't do it. Okay, so the bottom line is, you always end up having to create indexes. And even here, right, in this NoSQL database, you can see that they've created indexes across these tables where they have had to identify which table, so the customer table, the order table, which fields inside the JSON record they want to create. And even here, they're going through a shredding process where when a customer record is created, it must be shredding the JSON to figure out how to populate that index. So what we're saying in the Trellis Spark is no different than what's happening here, right? I mean, at the end of the day, the JSON record coming in is being shredded, it's being used to populate an index.
And other technologies as well, Tony, like Document DB for Azure, AWS Document DB, they're all doing the same thing too. They index all of these fields and tables that you're basically storing so that then you can quickly search them.
Exactly, right? I mean, there's no smoke and mirrors here, right? I mean, at the end of the day, if you want to query a data set efficiently, then you need that data set indexed. The only question that you're really trying to consider is how are you indexing the data set? So as I say, with the Trellis Spark idea, we create the lookup table so that we're not even looking at the entire records, we're looking at a small subset of fields for each of those records, and then we are putting relational indexes on those fields to optimize the queries. And that basically gives us a performance at least as good as a fully optimized relational database, but the advantage of being able to store the information in a single table in a data agnostic format. So there's no easy answer. At some point, you end up creating indexes.
Okay. So we've created these indexes. Are we not creating a lot of code for the lookup tables and indexes? So we've gone from the process of having one table, and then we've created these lookup tables. But didn't we just have to create a bunch of code to create the lookup tables and the indexes and everything? So are we not still just kind of circling around the fact that we still need to create the stuff? How are we actually addressing that?
So in Trellis Spark, what we did was that we knew that to create the full CRUD model, so the single page application, it's not just the fact that you want to get the data agnostic record storage right. You need to be able to pull the customer record or the order record out of fully data agnostic record storage, but you still need some sort of user experience. You still need to be able to say, I've got a customer here, I'm going to display it like this to this user. So one of the things that we were looking at when we built the Trellis Spark solution is that we needed to create the user experience as well. So for the user experience, essentially a customer as a form is a set of tabs. Each of those tabs has a set of rows and has a set of fields, and those fields are going to take data out of, in our case, an XML element and render it on the screen display. So what we looked at doing was saying, well, okay, you know what, I've got this data agnostic XML record sat over here. I've got this customer form definition over here that tells me here are the tabs, the rows, the fields. Okay, can I create all of the lookup tables I need from those two pieces of information? And the answer is yes, right? Because what you can do is that you can look at your form definition and say, you know what, this form is a customer, it's got all of these fields in here that I'm going to render. So what I can do is I can look at that form definition and say, well, okay, do I even need a lookup table? Is this thing actually going to get queried enough that it's worth creating a lookup table in the first place? If the answer to that question is yes, it's worth creating the lookup table in the first place, then great, let's do that. And we can decide whether or not we're going to pull all of the possible elements into our lookup table or a subset. And ideally, you'd want the smallest subset of fields that you can get. So essentially what we did with Trellis Spark as an example is we said, well, look, you know what, instead of having to rewrite all of this code, let's auto-generate the code that we need based on the form definition that we're actually going to display. Because when you think about it, right, the lookup tables you're going to need, you need them to power the user experience.
Right.
You need them. If you're going to query an insurance policy for a list of makes and models, that's part of your CRUD functionality, it's part of your user experience. It must somewhere be on a form definition that you actually need make, model and vehicle information in that data. So, you know, why not use that data to generate the lookup tables? And then that way, all right, we can regenerate those lookup tables on the fly and make sure that they are an accurate representation of the sorts of information that we're storing. So that's how we work through it. Okay, we actually used our CRUD single page application form definitions to actually generate all of the lookup tables and most of the indexes we needed immediately.
So it sounds like the lookup tables and creating it this way, where we're doing it in kind of like an auto-generated fashion, but based on whatever criteria we have around the form definition for it or whatever, that is giving you a lot more flexibility in what you're doing and the fact that you have everything in one table and then you can optimize your lookup tables. Is that essentially what you're saying?
Yeah, absolutely. So on the command side, we're storing everything in one single instances table, which is completely data agnostic. It doesn't care whether the record in that table is a customer, an order, a vehicle, whatever. Okay, it's there. Okay, and then what we do is we auto-generated, all of the optimized lookup tables to really optimize that function. Okay, now with Trellis Spark, again, one of the really cool things that we do is that this is code that you can deploy on-prem. Right, so you can take that code that we've auto-generated for you and optimize it further. You've got direct access to the database, right? So if you look at a lot of no-code, low-code solutions, you don't have that database level access, particularly in, say, a multi-tenant solution. So if you were trying to do this in Dynamics, the answer is no, you can't do it because you cannot go into the Dynamics database and make those sorts of changes, okay? But the idea with Trellis Spark was, let's have the best of all worlds from the command side, and then let's have the best of all worlds from the filtering and searching side. We'll create the code, we'll do the code generation to basically make that easy, and then it's all surfaced as part of the customization set so that any user or developer can go in and optimize that further if they feel the need to.
Okay, so lots of options around optimizing search and queries. Even going beyond what's auto-generated, you can optimize it even further, even if you really needed to. Then what are the benefits of putting all your data in one table? What are the other benefits outside of the fact that you could optimize these lookup tables and all of this stuff?
Yeah, so this is awesome, right? I mean, one of the things that I still am excited about years after developing this basic technology approach. It's a gift that just keeps giving, okay? Is that once you've made the decision to put all of your data into one table, right, is that you can go way beyond standard single page application CRUD functionality, okay? So essentially what you can do with your single page application and creating a page builder, as I say, is that we have got a completely agnostic record, and we have got a form definition that we also save as a data agnostic record, right? So essentially what we're doing is we're going to one database and saying, give me a bunch of records, right? Give me the record that I need to display, right? So let's say we've got one table for records. Let's call it instances. So that's the name we chose in Trellis Spark. So we have an instances table. And that instances table has all of the actual data in the database that we're going to maintain. Okay, one record equals one row in that database. Okay, so immediately the fact that we've only got one table means I only need one save instance T-SQL. I only need one read instance T-SQL. I only need one delete capability. So instead of having hundreds or thousands of insert, update, delete T-SQLs in the database and data models and functionality and code to deal with all of those things, I've narrowed that code down to a couple of hundred lines of T-SQL. Okay, it's really small, it's really narrow, and it's doing a hell of a lot more than CRUD functionality. So for example, right, we added an extra table called instance history. Okay, and what the instance history table does, it's very similar to the instances table, only that it stores every version of every record that was ever put into the repository. So when you create the first version, it's version 1, you make a change, you've got version 2, you make another change, you've got version 3. So we've added row level version control by adding one table called instance history. And then when a record is saved, part of that save processing is saying, what? Copy the new version into instance history and update the existing version. So again, it's like milliseconds, less than milliseconds to execute. But I've now got row level version history on every record of every type of data held in the database. So I can basically go in and say for this customer, it was, it's been changed 10 times. Here is the user and the date and time that change was made. So I've got full write audit control. Okay.
Nice.
Another example, that we put in was we added an extra table. Okay, so one extra table called instance access. And what instance access does is it tracks which users and groups have access to any particular record. Right. So essentially what we did was we built in row level access control at the user or group of user level by adding one extra table. And then whenever I want to query the information, I can execute a check to see, well, OK, does this user have access to this record? And if they don't, then we block access. So from a security perspective, we added one table. Part of reading the record, when I look at this record instance GUID, does this user have access to this record? Yes or no? And the answer is yes, you can see it. If the answer is no, then we throw it out. It's a security problem. So row level security was one table, few lines of code. We added a table recently called instance bookmarks. Okay, because we had a client that needed to be able to bookmark records that users were working on. So we added an instance bookmark table that says this user, right, has bookmarked these records. Okay, so essentially what we've got now is the ability that when a user is displaying any record on a single page application is that they can click a button that says bookmark this record. It gets added to their list of bookmarks. And now I can bookmark any record in the database. I don't need, if you think about it, if we had like the customers and the orders and so on, okay, these three solutions, if I wanted, instance history on customers and I had a customer table, I would have a customer history table. I would have a customer access table. I would have a customer bookmark table. Okay. Yeah. The fact that I don't have to have a customer table at all, I've just got an instances table, means that I can implement all of this functionality just by adding three simple tables. Okay. So this is a simple example of how we're adding some very complex functionality with a few lines of code that really make our single page applications go well beyond CRUD. I mean, we call this CRUD Plus inside Trellis Spark. We're going way beyond the standard capabilities. And then the other thing, okay, is, hey, you've got this instances table. I mean, if you think about that example we were looking at from MongoDB, the customer table had a primary key and then the JSON record. Okay, I mean, that's a very bare, sparse table, right? I mean, it's just got two fields. It's got a key field, it's got a JSON table field, okay? But we can actually, because we've got this instances table, we can put some really interesting metadata on that instances table so that we can, store a lot more contextual information about the record we're looking at. So, for example, we can add a parent GUID to that so that we know what the parent of this record was. So this order, its parent is this customer. Okay, we can do further. We can go and put a whole hierarchy in. So this order line, its parent is this order, and its parent is the customer. So we can actually maintain a hierarchy. Say, well, okay, customer order, here is the order lines, right? We can put in a whole bunch of demographic columns. So as I explained with the instance history, one of the things that we tend to add to our instance records is who created it, when was it created, okay, and when we modify it, who inserted and when was it inserted? So when has it been changed? Right. Yeah.
Which is great for like audit trails and stuff like that.
Exactly. Right. Now, in our single page application, the single page application is just told to load record X. Right. So it's got to go to the database and say, well, OK, I've got record X. I've got no idea what the hell record X is. OK. But one of the things that we tagged into our instances record was, OK, here is the form definition that you need to use to display record X. So when the SPA says load record X, right, it basically goes in and says, OK, I've got record X. What are you, record X? Well, record X is a customer. Great, let's pull the customer form definition out of the cache and then display record X, right? It's really easy.
Nice.
Another thing that comes up quite a lot is locking, right? So, I mean, we need a way of locking records. So if we're making a complex update where we do need to ensure the consistency of a set of information. So, for example, let's say it's a complex order and we're going through fulfillment. I don't want to be fulfilling part of the order and somebody else doing something else on that order, that basically breaks it. Okay. Now, we could try and wrap the whole thing inside a transaction and we're locking tables and everything else, right? So, I mean, we could build basically a big transaction-based system to do it, or we could actually put a lock on the record and say, well, okay, let's have an instance lock field that says if I need to actually lock this instance while I make a bunch of changes underneath it, that nobody else is basically going to get access to that particular record. And we can do that without putting transaction locks on the database and basically ending up in a bunch of locking conflicts, right? So, again, one of the things that we looked at when we were doing the detailed theory about the data analytics here is, is it better to use transactions or is it better to use optimistic locking and then actually put a particular lock flag on an instance record to actually increase the performance? So once you actually move to the idea of agnostic record storage and you say, well, okay, really, on the command side, let's get rid of the customer table, the order line table, the item table. Let's just consolidate it into one table. There are a huge range of benefits that you get from doing that. And there is a cost. Whenever you're doing this and you're putting all of this functionality into writing the record into that one table, there is a cost, but that cost is measured in milliseconds to actually execute this more complex logic. But you've then got row-level version history, row-level instance history, bookmark anything you want.
Yeah.
Create full single page applications that are totally data agnostic. I mean, there are so many benefits from doing this. And every week, every month, as we're developing further in Trellis Spark, we find another example where adding a few lines of code here makes it so much more efficient to do some online functionality further on. So the compromise of just having the one table, although it seems like at first blush, that's a really big mistake, okay, actually turned out to be a huge win. And then looking at, as I say, the underlying fundamentals about how the data is used and how we need to optimize and process that data further on gave us so many knock-on wins. I mean, it was just awesome.
So this is like a lot of really interesting academic concepts, emerging concepts around leveraging things around data agnostic services and how you could implement something like this. What can people see actually as a working model in practice around this? What are some of the resources that we already have at Great Ideas for people, for developers to be able to see this actually in action and how it works?
Yeah, so I mean, we've been doing this now for about a decade. Okay, so we've got a lot of experience working with data agnostic record storage, single page applications. Initially we were doing all of this in the Microsoft.NET framework, Windows 4.x, essentially using web forms. So we've got a lot of experience with building it there. For the last couple of years, we've been migrating that from web forms into Blazor technology, Blazor WASM in particular, was the approach that we adopted. And we have learned a lot over those 2 years about how Blazor works and how WASM works and how to build the REST APIs and optimize all of this. So we spent years figuring this out, decades figuring out the basics of the architecture, and then years figuring out how do you actually optimize this for use in the latest .NET 6 solutions and Blazor WASM framework. So we have got it working. It works really well. It's very impressive as a framework. Now, one of the things that we're doing is that we know that people are probably listening to this and thinking, seriously, vendor speech, blah, blah, blah. You've told me all of this great stuff. Is it really true, right? Are you just blowing smoke again, right? So we have made a ton of our content from our developers available on our greatideas.com website and in our Trellis Spark Academy. So all of the lessons that our development team have learned over the last 2 years, migrating from .NET 4x into .NET 6 and Blazor, are there, right? So you can learn a lot about building single page applications, about using Blazor, about using data agnostic record storage, page building technologies and things like that. That's all available for free at our greatideas.com website inside our Trellis Spark Academy. If you choose to take the next step, if this is interesting and you choose to join the Great Ideas portal, you can also download the latest release of Trellis Spark. So the Trellis Spark release contains a compiled version of all of our REST APIs. It contains a version of our latest database. So it's a Microsoft SQL Server database that uses this code building technology to create lookup tables. It's got a whole bunch of samples and example functionality in there. And you can actually deploy this on your own infrastructure. Okay, so you can download this application framework onto your infrastructure, start it up, and it will work. Okay, you will see the full version of everything that we have done. And because we love Blazor so much, I mean, this new .NET technology is absolutely awesome. One of the biggest asks that we've had from our customers over the years has been, well, can I customize the user experience beyond what you provided for me? So what we've done is we've actually open sourced all of the source code related to building the user experience. So you can see how we are using this data agnostic record storage, how that then is being fed into our single page application, and how that form definition is then being rendered in Blazor website. And as we move into Maui technologies, we'll also be open sourcing all of the Maui hybrid Blazor solutions so that you can see how our SPA page builder works across desktops and tablet devices and so on. So there's a full framework for you to download and play with. We've tested it. We've done it with lots of customers over literally a decade. Our new framework is just rolling out now. So our latest Trellis Spark framework, we're on release 2 deployed. We're currently working on release 3. And essentially, it's there, it's solid. We'd love you to try it out and play with it, right? Because, this whole idea around data agnostic services, I mean, this is going to be the future of development for the next decade. I mean, we're already seeing people moving towards single page applications, the document DBs, the microservices. Data agnostic services is obviously the next integration of all of that functionality and the next step in the process. And with Great Ideas, we've taken that step. We've figured out a lot of the issues, and we're making all that information available to you today.
Very cool. Yeah, and definitely we're not blowing smoke. This stuff is definitely real. It definitely works. And the other thing I would note is we do provide additional services, training, support, anything that you might need as far as getting your team ramped up to be able to work on this type of technology. And by all means, give us any feedback that you can. We really appreciate it. To learn more about Great Ideas products and solutions, visit greatideas.com. That's great ideas with a Z.com. Thanks.